Hi, thank you for joining us. And if you can remember, last week we went over algebraic equations. So this week we'll be looking at some more algebraic equations, so we'll be revising them. So let's hop straight into an example. So in an example, we are given 3x minus 4 is equal to 11. So the first step we're always going to do is try and identify our variables and our constants, okay? So straight away we can see 3x has its variable, and then for our constants we have -4 and then 11. So what we're going to do is we're going to keep the variables to the left side of the equal sign and take our numbers over to the right hand side. So we can see that we have 11 here on this side already, so we're going to take 4 over the equal sign. But remember that when we take it over the equal sign, the sign changes, okay? So from a negative, that will become a positive now. So what we're going to be left with on the left hand side is 3x, and now the right hand side will look something like this. It will look like 11 plus 4. Remember, it becomes positive 4 once it comes over, okay? So we'll be left with 3x is equal to 15.
Oh, we can my favorite today.
So now what we're going to do is try and get x left by itself. So we're going to divide by 3. And then the 15, we'll have to divide by 3 as well, because what you do to the one side, you need to do to the other side as well. So now what's going to happen is the 3's are going to cancel each other out. So we're going to be left with x. So then we're going to have 15 divided by 3 as well, which is going to give us 5. So x is equal to 5. So the very important thing was, firstly, we identified the variables and then the constants, okay? So we're identifying the like terms first, and now our variables are always going to come to the left and our numbers to the right, because that's how we prefer it, okay? Once we did that, we could add and subtract like terms, and because x was not by itself, we had to get x by itself by dividing by 3. Cool. So let's move on to another example. In this example, we're given x over 5 is equal to -3. So looking at this, we can see that we have x here, but it is being divided by 5. So we have a 5 underneath at the bottom of the fraction as the denominator, right? And on the other side, we have -3. So once again, x is not by itself. We have to try and find a way to get x by itself. So how are we going to get rid of a denominator in a fraction? Well, if you can remember, when we're timesing fractions, we can do cross cancellations, right? So if we were timesing this side by 5 over 1, so we're timesing it by 5 over 1, we can cancel out the 5's, right? And then we're left with 1a. So basically what's going to happen is x is going to be left by itself now, right? So if there's a denominator we're working with, we can times the side by 5 if the denominator is 5. If the denominator was 2, we could times the side by 2 to get rid of the denominator of 2, okay? And remember, what we're doing to the one side, we are also doing to the other side, so we're timesing this side by 5 as well. So what we're left with is, so it's a negative times a positive, we can get a negative 3 times 5, which is 15. Therefore, x is equal to -15. Now moving on to another example. In this we have -8, x is equal to 72. So in this case, we're pretty much at the final step already. So all we're going to do is get x by itself, right? But there's one difference here. We have a negative sign here in front of the 8, right? And remember, we can't have x as a negative in our answer. So what we're going to have to do is, we're not only just dividing by 8, but we can divide by -8. Okay? So what we do to the one side, we do to the other side. So we have -8 once again. So what's going to happen is, we're going to get Negative 8 cancelling out negative 8. So we're going to be left with x on this side. And then this is a positive divided by a negative. So our answer is going to be a negative. 72 divided by 8 is going to give us 9. So our answer is negative 9. So moving on to this example now, we have 2x plus 1 is equal to 7. As you can see, we're starting off with a bit of basic examples. So we're going to have 2x, right? Because we're identifying like terms, we have our variable here. This is our number, we're taking it over. So we're going to have 7 minus 1. Remember, the sign in front of the 1 changes, right? So we're going to have 2x is equal to 6. Getting x by itself, we're dividing by 2. So we divide 6 by 2 as well, because what we do to the one side, we need to do to the other side as well. 2's cancel each other out. We can be left with x is equal to 6 divided by 2, which is 3. Okay, so moving on to this one now, we're going to have x plus 2 is equal to x plus 2. So the next two examples I'm going to be doing is very special cases that we can come across in algebraic equations. So just try and pay attention. So we have 6 plus 2 is equal to, x plus 2 is equal to x plus 2. So our common factors are x and x. So we're going to have x, this x is coming over, so it becomes negative x. We're going to have 2 here. This 2 over here is going over, so we're going to have a negative 2. So we can see here we have x minus x, which is going to give us 0. And 2 minus 2, which will also give us 0. Right? So when it comes to this case where we don't have any values left over and if 0 is equal to 0, our answer that we will give them is therefore x is an element of all real numbers. So that's how we write this out, okay? X is the element of all real numbers. So that's the first special case that we can come across. The second case is where we're given something like x plus 2 is equal to x plus 3. So if in this case, what's going to happen is same thing, we're going to bring our x over. So we're going to be left with x minus x is equal to 3 minus 2. Because this positive 2 is going over the equal sign, okay? So the sign changes to negative. So what's going to happen is now x minus x is 0. 3 minus 2 is 1. So in this case, you can see what happened is x cancels each other out, itself out, right? And we didn't get to a final answer for x. So in this case, we'll say, therefore, x has no solution. So let's try to identify the key points in these special cases. So we got to x minus x, 2 minus 2. We could see that it gave us 0 is equal to 0. And our statement that we gave them was, therefore, x is the element of all real numbers. In our second case, we could see that we just got x minus x, which would obviously cancel it out to equal 0. And we didn't get a final answer for x, so therefore our statement is, therefore x has no solution. Cool. Looking at number 7, they give us negative a plus 4a minus 7a is equal to negative 20. So if we're going to look at this, we can see we have all of our like terms on the left hand side, right? All of our variable terms, and our constant is on the right. So we can just go ahead straight away and work this out. So we're going to have negative a plus 4a. So that's negative 1 basically plus 4. So we're going to get 3a, right? Positive 3a. Now we're doing minus 7a. So positive 3a minus 7a, we're going to get negative 4a is equal to negative 20. So if you can remember from earlier, now what we have is a negative, right? A negative in front of this 4. So we know that if we divide by 4, we're going to be left with a, right? But we're also going to be left with that negative. So we don't want our variable to have a negative attached to it, because that we can't have an answer with a variable with a negative attached like that. So what we can do is we can divide by negative 4, so they can cancel out the whole of this negative 4 over here. What we do to the one side, we need to do the other side as well. So we have a negative 4. So now you can see that the negative 4 will cancel out to the negative 4. So what we will be left with on the left hand side is going to be a. And that's equal to, so we have negative 20 divided by negative 4. That's a negative divided by a negative, so we get a positive, okay? So we know we have a positive, then it's 20 divided by 4, which is going to give me 5. So therefore a is equal to 5. Moving on to example number 8, we have 3y minus 1 is equal to 6. So we have a bracket in this example, right? So how we're going to deal with that bracket is we're going to times the number into the first term in the bracket and then into the second term. So the 3 is going to times the y first, then the 3 is going to times the negative 1. So we're going to have 3y, right? Because that's 3 times the y, then 3 times negative 1. We're going to get negative 3 is equal to 6. So what's now going to happen is we're going to have 3y left on this side, because if we're identifying like terms, we have just that over there, and then we have negative 3 and 6. So let me just put that in a different color. Negative 3 and 6, right? So we have 6 now left over here still, and then the 3 is going to come over and it's going to become positive, right? So we're going to have positive 3. So we'll have now 3y is equal to 9. Now we need to divide by 3 to get y by itself. What do you do to one side, you always do to the other side. So we're left with y is equal to 9 divided by 3 is 3. Okay, moving on to the next example. We have 2, open brackets, 3y plus 2 is equal to negative 8. So once again, what we're doing is we're timesing into the brackets, right? So we're timesing out the brackets, so we're going to have 2 times 3y, which is going to give me 6y, and then 2 times positive 2, we're going to get positive 4, and we're going to be left with negative 8 on this side. So what's going to happen is we're going to look at our like terms again. We have 6y with the variable, and then we have positive 4 as a constant and negative 8 as a constant. So we're going to be left with 6y on this side, and we're going to have negative 8. The positive 4 is going to come over, we're going to get negative 4. So now what's going to happen is we have 6y staying the same on this side, and then negative 8 minus 4, so we'll have negative 12, right? Because if we minusing two negative terms from each other, we add the numbers together and keep the sign. So now what's going to happen is we're going to divide by 6 to get y by itself. So what you do to the one side, you do the other side. So we're dividing by 6 again. Sixes cancel each other out. So we're left with y on this side. And we have negative 12 divided by 6. Negative divided by positive. So it stays a negative. 12 divided by 6 is equal to 2. So therefore in this case y is equal to negative 2. Okay, thank you so much guys. That's the end of the recording.